Okay, so we have the worksheet which compares displacement time graphs and velocity time graphs. We use the symbol S for displacement and V for velocity. So ST graphs are displacement time graphs. They are not speed time graphs. Okay, so letter S stands for displacement. So for the first one, object at rest, all right, there are two possibilities for the displacement time graph. Intuitively, we all know that if the line is at the axis at 0, that the object is stationary. But if the horizontal line is above the axis, the object would still be at rest. So whether the horizontal line is at the axis or above the axis, the object is not moving. So for example, if I'm standing 2 meters away from the starting point and I don't move after 5 seconds, 10 seconds, I'm still at 2 meters away from the starting point, my displacement would have been the same and I would have been at rest. So the horizontal line need not be at the axis for the object to be stationary or at rest. Okay, then for velocity time graph, obviously the velocity will have to be 0. So the line would have to be at the axis, right? Because the velocity would have to be 0 in order for the object to be at rest. Okay, let me see if I can increase the thickness of this. All right, okay, next, object moving at uniform velocity. Okay, uniform velocity, we must remember that for a displacement time graph, the gradient, all right, of a displacement time graph will be the velocity, because we are talking about the change of displacement divided by the change of time, right? So I put it here in brackets, which is the change in displacement per unit time. All right, so that is why the gradient of a displacement time graph is velocity, and since the velocity is uniform, it means that the gradient is uniform, right, or constant. So you have a constant gradient. Okay, so constant gradient means constant velocity. All right, okay, so constant gradient for displacement time graph means that the object is traveling at constant velocity. So for velocity time graph, it is quite obvious. The velocity would not be changing. It will be constant. So it's a horizontal line. All right. Now for object moving at uniform acceleration, okay, remember that for displacement time graph, the gradient is velocity. So if the velocity is increasing, that means that the gradient is increasing. So for increasing gradient, it means that it has to be from gentle slope to a steeper slope, right? So it will look like this. Okay, from gentle to steeper slope, okay, the gradient of a displacement time graph is velocity. So when the velocity increases, the gradient increases. All right, so I write down here, velocity increases, gradient increases. Okay, then for velocity time graph, right, for velocity time graph, the gradient of a velocity time graph is acceleration. So let me write this down. The gradient of velocity time graph gives you the acceleration. All right, because acceleration is the change of velocity divided by the change in time. So effectively, when we say change of v over change of t, we are saying that that's the gradient. All right, so when the acceleration is uniform, that means that the gradient of this velocity time graph is uniform. Okay, so constant gradient. All right. So to repeat, okay, the gradient of a displacement time graph gives you the velocity, while the gradient of a velocity time graph gives you the acceleration. All right. So next, object moving at uniform deceleration. Deceleration means that the velocity is decreasing, right? So if the velocity is decreasing for displacement time graph, the gradient is decreasing. That means that it is the slope is becoming more and more gentle, less and less steep, right? So it looks like this. Okay, I didn't draw the last part very well. It should be a horizontal line at the end, right? Because eventually, when it is moving at uniform deceleration, eventually it will reach, it will slow down until it is stationary. So eventually, the object will stop moving, and therefore you reach a horizontal line, which means that object is stationary. Okay, so the gradient of a displacement time graph is the velocity, and the velocity decreases, so the gradient decreases. Okay, I should write the V on V first lah. That means when we know that velocity is decreasing, therefore the gradient is decreasing. Okay, so let me erase this. It's the same. Okay, basically velocity decreases, therefore we know that the gradient of a displacement time graph decreases. All right. Then for velocity time graph, uniform deceleration, since the gradient of a velocity time graph is acceleration, and deceleration means negative acceleration, that means that I'm trying to draw, but it is not coming out. Right, so the when we say deceleration, it means that it is negative acceleration, right? So negative acceleration means negative gradient, right? And it is constant or uniform, so it's constant negative gradient. Okay, right? So you have a uniform deceleration. Okay, let's move on to 4. These are the more, I would say, not so common graphs where the motion is non-uniform acceleration or deceleration. So we don't usually draw displacement time graphs for these because it is not very meaningful. For example, if this is a displacement time graph, right, and I have uniform acceleration, it will look like this. Okay, because acceleration means velocity is increasing, so the gradient is increasing. Now, if the acceleration is increasing, all right, you still have a curve, but with a larger gradient. So you won't be able to tell without a proper scale whether it is uniform or non-uniform acceleration. So it is not meaningful to use displacement time graphs when it comes to acceleration and deceleration. So we will only be investigating the velocity time graphs. Okay, so when we look at, okay, the first one, increasing acceleration, it tells us that acceleration means that the velocity is increasing, and we know that the gradient of a velocity time graph is acceleration. So when it is increasing acceleration means that the gradient is increasing. All right, let me just write this to remind us. Or actually, I can just copy this thing over. Let me just copy this over. Can I do that? Yeah, I think I can do that. Okay, let me paste it over here. Can I just paste it here? Right, okay. So to remind us, okay, the gradient of velocity time graph is acceleration, all right? So since the acceleration is increasing, means that the gradient is increasing. So our line over here would have increasing gradient, okay? So that shows us increasing acceleration, right? The gradient is increasing, right? Because acceleration is increasing, okay? So next, decreasing acceleration. Now, decreasing acceleration is not the same as deceleration, right? It's not the same as deceleration. All right, deceleration means that the object is decreasing in its velocity, all right? But decreasing acceleration means that the acceleration, there is still increase in velocity, but the increase in velocity is, the rate of that is decreasing. All right, I say again, there is still increase in velocity, but the rate of increase is slowing down or decreasing, right? Which means that the gradient of this velocity time graph is decreasing. So decreasing gradient, how does it look like? It looks like this, right? So at the end, okay, over here, the velocity becomes constant because acceleration is zero. So eventually it will reach a point where acceleration has decreased until it is zero and the velocity is constant. All right. So over here, the velocity, the acceleration is decreasing. All right, acceleration is decreasing. So the gradient, okay, is decreasing. All right, remember that the gradient of a VT graph is acceleration. So when the acceleration decreases, the gradient decreases. All right. So next one, we have increasing deceleration. So what does this mean? Deceleration means that the velocity is decreasing, right? So the line will be going down. And increasing deceleration tells us that the gradient is becoming steeper and steeper, right? The line is going down, but it's becoming steeper and steeper, so it will look like this. Okay, so the gradient is becoming steeper and steeper, right? Okay, and finally, decreasing deceleration. The line is going down because velocity is decreasing, okay? But it's decreasing at a decreasing rate, meaning that the gradient is becoming not so steep, okay? So the line is going down, but the gradient is going to be decreasing, all right? You contrast with this one, the gradient is increasing, although the line is going down. Here, the line is going down, but the gradient is decreasing, so you look like this. Okay, so the gradient is decreasing, and the line is going down because it's decelerating. All right?